Okay, here's our warm-up of 6 questions. This was your homework if you're in the other grade 9 class, and if you're in this grade 9 class, this is the class you did for your warm-up. So the first question says, write as a power and simplify to standard form. So we really have law 3 in action. We have a power set to an exponent. Our rule is keep the base and multiply your exponents, which will mean as a standard power, it's negative 2 to the exponent of 12. Now, without simplifying this to standard form, do we know if my answer is positive or negative right off the bat? Yes. We know that if you have a negative base to an even exponent, you will always have what type of answer? Correct. You'll always have a positive. So negative 2 is your base, 12 is your exponent, is positive 4,096 in standard form. The second question gives us the product of two numbers in brackets set outside to an exponent. The two ways we can solve it. First way is just use bed mass. 3 times 5 is 15. And 15 cubed is 15 times 15 times 15, which off the top of my head, I don't know. It's 3,375. Using exponent laws, we can reallocate this to both parts of my product instead. Give me 3 cubed times 5 cubed, or 27 times 125. And guess what? 27 times 125 is 3375. So the two ways you need to be able to solve it on your test is show me that you know how to do it with bed mass and solve it, and then show me that you know what the rule or the law is with products of numbers and brackets to exponents, and show it the other way as well. The second way says solve it as the product, or as a power and in standard form. Because we're multiplying two powers that have the same base, we can multiply it like that. Add our exponents to get 4 to the power of 8, which is 4 times 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 4. That's not right. Oops, clear. 4 to the exponent of 8 is 65,536. Our last 3 questions, we have a fraction to an exponent, or another way to think of it, conversely, we can think of it as being 5 divided by 6 to the exponent of 2. Both are the same thing. If we think of it as a fraction, we're just allocating that 2 to the numerator and denominator. If we're thinking of it as a division, we can do the same thing. So expressed as a quotient of 2 powers, we're going to have 5 squared divided by 6 squared, or 25 divided by 36. If I did it this way, I have 5 over 6 times 5 over 6, which is 25 over 36. Now, interestingly enough, it's actually better here if we leave it as a fraction. My answer is 25/36. If I convert it to a decimal using division, I end up with 0.694 repeating. Both answers are fine, either as a fraction or as a decimal, because we know they're the same thing. But simplified, it's 0.694 repeating to infinity. Our fifth question gives us the division of 2 powers, which is law 1, or law 2, excuse me. The rule is keep the base and subtract your exponents to give you 10 to the exponent of 2, which in standard form we all know is not 20, but rather 100. And finally, your last question. Is this read as negative 2 to the exponent of 0? Is that what it says? No, it doesn't. How do I know that it's not negative 2 to the exponent of 0? Because there's no brackets around the negative 2, which means that's not the base. What that really says is the opposite of 2 to the exponent of 0. And our law 6 says any base, whether positive or negative to the exponent of 0, has a standard form of 1. So this is really, since 2 to the exponent of 0 is 1, this is the opposite of 1, which will be a negative 1. The opposite of 1 is a negative 1. The second one says negative 5, which is now in brackets, to the exponent of 0. Any base to an exponent of 0, including negative bases, have a standard form of positive 1. So negative 5 to the exponent of 0. A lot of people think that's a negative 1, but it's not. It is a positive. Any base to the exponent of 0. This, the base is not negative. The base is 2. It's the opposite of 2. Divided by any power to the exponent of 1 is the base itself. Negative 1 plus 1 is 0. And half of 0 is still 0.